All right, guys, so this is 8A.3 part 2. We started this example in part 1, and we'll finish it right now. So if I start the synthetic division process, I would carry down the 1, multiply diagonally, and get -5, combine down. -5 times 0 is 0, combine down. -5 times -18 is a positive 90, which means that I do have a remainder of 0 again, which makes sense because this is a factor. If I decrease these by a power, because I divided a cubed by an x, this would be x squared plus 0x minus 18, which is just x squared minus 18 equals 0. And if I solve this quadratic, this one does not seem to be factorable, so I could rely on other methods like quadratic formula or completing the square, or the best one now would probably be square roots. Take the square root of both sides, I get x equals plus or minus root 18, which would be x equals plus or minus 3 root 2. So now I have all of my roots, x equals -5 and x equals positive 3 root 2 and negative 3 root 2. But the question asks for a function as a product or a multiplication of linear factors. So this is an example of a linear factor, x plus 5. So if I wanted to write my function f of x, one of the linear factors would be x plus 5, because that's where x minus 5 came from. And if I think backwards on these two, if I have a root of positive 3 root 2 comma 0 and a root of negative 3 root 2 comma 0, this one, the positive one, came from the root subtracted, and the negative one came from the root added. So if I write that more neatly, the product of my linear factors, we can keep it as a factored form, would be x plus 5, x minus 3 root 2, and x plus 3 root 2. So we found the answers first and then thought backwards. Now, yes, I could multiply this out completely, but if I would like, as the directions say, completely factored form, it would be too much work to actually go ahead and FOIL. So there's my final answer. All right, guys, that video is short and sweet. Good luck practicing this tomorrow.